Hello, Djordje Romanic here. Today we are going to talk about flying cars and how, in principle, we can make any object that has sufficiently high velocity fly thanks to the Coriolis force or thanks to the fact that our planet is rotating. The text of the problem is now on your screens. So you see, the problem says, let's say we are at the equator. This is 0 degrees or equator. And this is a car driving due east. This is east, this would be west. Velocity of the car is u. We need to find the velocity at which this car will detach from the surface and fly. Of course, I will take this to be my x-axis, this will be my y-axis, and z is coming out of the page. To solve this problem, we use the second Newton's law. And we will write the second Newton's law in the vertical direction. So mass times acceleration of this car in the vertical z direction is the sum of all forces that are acting on the car in the z direction. Okay, well, what are those forces? We have gravity and we have Coriolis force, and that's it. And Coriolis force is in the vertical direction. And that is called Eotvos effect. I have video on the Eotvos effect, so I suggest you check that. So mass times acceleration of this car is equal. Gravity is acting in the opposite z direction, minus mg. And we have vertical component of the Coriolis force. You will remember that was plus F prime times mass times u, component of the velocity. But we also have normal force N. Now let me sketch the problem so you know how we derived, how we got these three forces. What we have here, we have surface of the Earth. And we have car, okay? This is equator. Velocity of the car is like so, and that's u. What are the forces acting on this car? Gravity is acting down, and that is mg. And I hope you now know that this g incorporates both gravity, pure gravity, and centrifugal force. So this is the apparent gravity, what we called. Okay, so there is gravity acting towards the center of the Earth. But the car doesn't go through the surface of the Earth and it doesn't go up, which means there has to be normal force acting up, just like me standing on this floor. Gravity is acting up, down, but I'm not going through the floor, I'm standing on the floor, which means floor is acting with normal force N on me, and gravity and normal force are in equilibrium, and I'm not moving up or down. But there is also force acting up, and that would be Coriolis force due to Eotvos effect, because car is moving due east, and therefore it wants to fly up. If the car was moving towards the west, the Eotvos effect, Coriolis force, would act downward. So the car would be heavier. So you see, as this car is moving in the x direction, this is x direction, it is at first, it is not going into the ground, it is not flying away, which means there is no acceleration in the vertical direction. Car is just coasting along the x-axis, which means if we rewrite this, that n plus f prime, of course, f prime mu minus mg equals 0. What I wanted to say from my previous video, you know that f prime is constant 2 omega cosine phi, where omega is angular velocity of the Earth, approximately 7.27 times 10 to power negative 5 seconds, and phi is latitude, which is 0, which means this term is 1. So f prime is basically just 2 omega because we are at the equator. Okay, so we have this equation over here. Now we need to think about this problem. If the velocity, let's first discuss this. This term is unchanged. Gravity cannot be altered. But in order for the right side to be 0, if this is unchanged, as I am increasing velocity, n needs to decrease so that this is 0. Okay? So as u is increasing, n has to decrease so that everything at the end of the day is equal to 0. Because mass is constant, f is constant, and this is constant. That means at some point u will be so high, and we will call it u fly, that n is equal 0. And this term will equal this term. In other words, we will look at the moment when the velocity of this car is so high it is about to detach from the surface. At that moment, when it is about to fly away, normal force is of course 0. And that means that at that time f prime is 2 omega times m times u fly has to be equal mg. Masses cancel, and I get that u fly is equal g divided by 2 omega. And this is the velocity that car has to have in order to start flying thanks to the Coriolis force at the equator. If we are not at the equator, then here you would still have this cosine phi to account for different latitude. If we are at the north or south pole, then this is not possible, because you will have cosine of 90 degrees is 0, and therefore velocity needs to tend to infinity to get this effect, but that's impossible, of course. But we know that because the vertical component of the Coriolis force at the poles is 0 and maximum at the equator, and that's why we decided to use equator over here. So g is 9.81, omega 7.3 times 10 to power negative 5. So if you calculate if you plug in the numbers and calculate, the solution is, I think, approximately 67,000 kilometers. Meters per second. $67,000 meters per second, which of course is 67 kilometers per second. So you can see that this is exceptionally high velocity, but that's because Coriolis force in the vertical direction is very, very weak. Very weak, but it depends on velocity, so you have to increase velocity tremendously in order to beat gravity. So you can see that this is an interesting concept. Of course, there are many technical problems. First of all, we are neglecting aerodynamic forces associated with air going around this car at these velocities. This is supersonic. So this is crazy. Another, we are neglecting friction with the surface and so on. But nevertheless, it's a very interesting concept. It's in Tesla cars, there is a ludicrous mode of high speeds or high acceleration. We can call this Romanic mode. Romanic mode, this is Romanic number. Ratio between gravity and vertical component of the Coriolis force at different latitudes. Romanic was a great atmospheric scientist. He worked in the field of application of atmospheric sciences to Jiu-Jitsu, developed various theories how to apply armbar when it is raining outside and stuff like that. And these theories resulted in this Romanic speed, which is as useful as ludicrous speed in Tesla cars. You see, if you think about it, this car is even better than Tesla. Because if you are driving towards east at this velocity, you will fly. If you are driving due west with this velocity, you will start going into the ground, and that also goes into the direction of Elon Musk's idea of digging tunnels under the ground and connecting cities across North America through tunnels. So this concept covers both. If you are traveling due west, you will actually have weight increased, and at some point you will go into the ground, but of course then we would have to account for the strength of the ground. But I actually did that in one of my previous videos when I was talking about penetration depth of a bullet going through target. So here, same equations give same solutions, as Feynman said. If we consider that this car is bullet, if it would go into the ground, we can look into that problem just like we looked into the bullet going through target. I notice now I talk too much, but nevertheless, this is very interesting concept, and concept how to fly using Coriolis force. Until next video, goodbye.